Hey guys, welcome to the second episode on C STL for competitive programming and coding interviews. In the first episode, we talked about vectors, pairs, sets, maps, lower bounds, upper bounds, and all those kind of things. And we also solved a complex problem using sets. In today's video, I just wanted to talk about unordered map and also solve few problems in competitive programming or coding interviews using unordered maps, and then also compare the various solutions that we are going to implement. So to include an ordered map, you have to include this header, and then again map and an ordered map are nothing but they are mapping something to something. In this case, we have two maps of char to int, and there is a string s, and for each character in the string we are incrementing the count of that particular character, so we can use these two maps to find out how many times a character is present in the given string s. But if you'll notice over here, the time for this is n logN, where n is the size of your string. And in this case, the time complexity is just order n, because unordered maps can get the values and set the values in just order one time. And we are doing n operations, so this takes order n time, whereas for the normal map, it takes logN for every add operation and every delete operation. So what are the add and delete operations over here? The add operation is nothing but add this key comma value, right? So this takes logN time for ordered maps and order one time for unordered maps. And again, there are some things like erase key, right? So again, this takes logN for ordered maps and order one for unordered maps. So let's have a look at why unordered map can be so fast. So we had an unordered map from char to int, right? And what was happening was nothing but, let's say we are trying to do something like unordered map use C++. So what is it doing is, under the hood it's having an array, big array, and this character C that we are having, it goes to some hashing function which takes as input a char, and it returns a very big number. And then let's say the length of this array is m. So you take this result output and you do it modulo m, which generates one of the indexes varying from 0 to m minus 1, and you map this C to some particular index in this big array. Since this hashing function is a mathematical function, it just takes order one time to map a character to an index in the array, right? But what happens is that sometimes this hashing function might not be good and it can result in collisions. What I mean by that is, there might be a case where some other character, let's say $, when put to this hashing function, can generate the same output x which was generated for the input C. So in this case, $ will also get mapped to this, and then the internal C++ library will take care of handling these collisions. But the worst case in that can go to order n if they are trying to resolve the collision by linear probing method or some other probing methods. So in a nutshell, most of the time it's order 1, but in worst case, to resolve the conflicts, it can go order n. So this is how unordered map works. Whereas if we talk about simple maps, they maintain the sorted nature of the keys. What I mean by that is, let's say if you are having map of char to int, and let's say you are having values like a is mapped to 30, b is mapped to something, c is mapped to 100, and so on. So the ordered map or the normal map that we have is it's having a BST internally, and if you don't know BST, you should check that out, otherwise you won't understand what I'm talking about. But in BST, what happens is that, let's say this is the key. The keys are stored in the nodes like this. So this is E, maybe here is H, here is F, here is Z, and then let's say here is something like C, here is D, and here is A. So this is how map stores the keys. Since the key over here is a char, the map internally builds a BST on these char values. So basically, map always makes a BST on the keys, and this is how it's stored. And now let's say we have E is mapped to 200. So inside this node, it will also store 200 right over here. And let's say A is mapped to 30, so it will store 30 here. C is mapped to 100, it will store 100 here, and so on. So the value is stored inside the node, and the key which is char over here, is used to make this BST, right? So the BST is formed on keys and the values are stored inside each node, and this tree is always balanced. And what map does is, let's say if you are trying to increase some other key, it will just simply update this BST structure that we are having. So let's say if you are want to insert y with value, let's say -10, so it will say we have to insert y is greater than e, so it goes this side, y is greater than h, it goes this side, it's z, then it goes left, and it creates y over here, and the value set over here is -10. So this is what it does, and as you can see, the max it has to traverse is the height of this tree, and since it's perfectly balanced, the height can be max logN. So that's why map takes logN time to insert something, whereas another map was using hashing, which was just in order n time. So this is how maps differ from another maps. And if you'll see set is exactly this. So basically set is a subset of maps, because in maps we are having keys and we are also having values. In sets you can say that there we just have keys and BST is built on keys. That's it. So whatever operations you can do on a set, you can always do on a map. So if you remove these values, these orange color values that I have put, like 100, 30, 100, 200, -10. So if you remove this, so this is what a set looks like. So if you have a set of chars, it will be stored like this, and if it's a map of char to int, the value will also be get stored inside each node, right? So I hope now you understand how set and maps are working in a better way. I didn't want to go into all these details in the first lecture, but yeah, in the future videos as well, I will be going deeper into concepts. So make sure that you watch all the videos. So now you know how set works, how map works, how unordered map works, and why the time complexity for lookups is logN in maps, in sets, and why it's order 1 in unordered maps, right? I really don't want to talk about unordered sets because I have never used them. I don't feel there is some great use case for unordered sets. So I'm just going to cover these important things that you will be using in competitive programming or coding interviews. So why you should use unordered maps? Just because to get this order 1 time complexity. Of course the worst case is order n, but if your map solution is getting time limit error, the next thing that you can do as an optimization and try your luck is go for unordered maps, right? Cover one interesting problem so that I can close this demo on unordered map and map. So here is a question. It's a question on code forces wherein we are given an array and we have to see if we can split the array in two parts in consecutive sections so that the sum of the first part is equal to the sum of the second part. And the twist over here is that we can also pick one element, exactly one element, and put it in some other position in the array. So in this case, as you can see, we can't do anything. We can't divide the array into two parts, two consecutive parts, right? But if we delete 3 from here and put it after 2, the array becomes 1, 2, 3, and then 1, 2 can be the first part, and the other part, which will only contain 3, are exactly the partitions that we have created with equal sums. In this case, in 1, 2, 3, 4, 5, you can't do any operation. In 1, 2, 3, 4, 5, you cannot delete any element and put it in some other place and divide that into two parts. So answer for that is no. And the answer for this is again yes. And how? As they have mentioned, the fourth element over here can be moved one position to the left. So basically the array becomes 2, 2, 4, 3 and 5, and then 2, 2, 4 is the first part and 3, 5 is the second part. So we'll quickly implement this in C++ and then close the session. Alright, so what is the, let me quickly delete all this. We don't need this. So initially we have an int n, cnn. Let's have a vector of int. Let's call it a and initialize it with all zeros. Now let's quickly have now let's quickly take the input. Oops. cnai. Awesome. And now we have to check if we can divide the array into two parts, right? I will quickly move to the whiteboard once. So we were having 2, 2, 3, 4 and 5, and the answer for this is we perform exactly one operation wherein we remove 3 from here and insert it right over here. So array becomes 2, 2, 4, 3, 5, and then we do the partition right in between, so that this is 8 and this is also 8. So for small numbers we can do this, but how do we do this programmatically with some algorithm? It's not that difficult, to be honest. Now whenever we have an array, right, the sum of that, let that be s. So of course whenever we are doing the partition, the sum of the first half will be s by 2 and the remaining half will be s by 2. So what I am going to do is I'm going to iterate on all the prefixes or all the first parts that are possible. So now let's say we are at position I. So this is I and this is maybe s dash, right? Now what I'm doing is I'm considering that this is my first part. So if s dash is s by 2, then I am done. I know that this is where I need to partition, right? Because s dash is s by 2 and we have done what we were looking forward to. But if that's not the case, what can happen is s dash is less than s, or the other case can be. So if that's not the case, and let me clear some space. So there are two cases possible. The first is s dash is less than s, and the other s by 2, and the other case is s dash is greater than s by 2. Because if it was equal, we were done. We will simply print yes and exit. So now let's consider each case one by one. If s dash is less than s by 2, it means that the number that we have to delete lies in the second part. And what exactly do we need from here is, now let x be s by 2 minus s dash, and we need exactly some element x from the second part, and if such a element x exists in this section, we can simply delete it from here and put it in any position in this area, so that the overall sum now becomes s dash plus x, and s dash plus x is s by 2, and then we will simply partition the array right over here. So in this way we can find some. So in this way, for some I, if we know the sum of the first I numbers, we simply compute x and then see if the remaining part of the array is having that element x. If it has, we can simply print yes. The other case that we were having was that s dash is greater than s by 2, which means we need to remove some element y from here, so that this sum s dash can be reduced up to s by 2. And what is that y? Y is nothing but s dash minus s by 2. So in this case, we had to look for some y in the first I numbers, and if such y existed, we'll simply delete it. We simply delete it from here and insert it in the second part of the array, and we can simply print yes. So as you can see, in both the cases, we are either performing a lookup of some number in first I numbers, or we are performing a lookup in the last n minus I numbers. This is what we are trying to do. Let me clear the screen again. So what we are going to do is, initially we are at I equal to 0, and we are having two maps, and this is having nothing but a0, and we have other map which is for the suffix, and it's having all the numbers from a1, a2 up to a n minus 1 if there are n numbers. So this is the other map. This is the first map with only first element. And whenever we have to perform a lookup, we will simply search in these two maps whether some element is present or not. Okay, so map of what? Map of int to int, and a0 is mapped to 1, that it means it exists, and over here all these numbers, a1 is mapped to 1, a2 is mapped to 1, which means they exist. So we can use these two maps to find out in logN time whether some element x or y exists, right? So now I is 0, this is this, this is that. Based on whether s dash is less than s by 2 or greater than s by 2, we will either perform a lookup here or here, right? Now what happens as we move from I equal to 0 to I equal to 1? So now we have to insert a1 over here, which is mapped to 1, and from here we have to remove a1, so we can basically decrement the counter of a1. right? And now let's say once we transition from I equal to 0 to I equal to 1, and we also make these transitions of inserting a number over here and deleting a number from here, our maps always stay updated, and again we can perform lookups on them in logN time and have the correct data set to find exactly the answer that we're looking for. So let's quickly implement this and try to submit it. So I need two maps, so I will have map int to int first and then second. Alright, so first is 0 equal to 1, and then what we can do is for int I equal to 1, I is less than n, and I plus plus, we can insert all those numbers in the second map. And why I am doing plus plus over here and not equal to 1? Because the array can have duplicates, right? So if the second part of the array is having the number 3 5 times, the count of that should be 5. So that's why I'm doing plus plus over here. Now what we are doing is we're iterating on all the possible prefixes, which can be up starting from 0 up to n minus 2. So that's why I is less than n minus 1, right? And now we int cur equal to 0, or we can say s dash, right? S dash, which is the sum of the first I numbers. So s dash plus equal to the current number. So now we have the sum of first I numbers, right? And we also need the total sum of the array. So let's also quickly calculate that. Let's have long to avoid overflow. S plus equal to AI, and also let's make this long to avoid overflow. Alright, so first I numbers over here, and what we can do is if s and 1, which means if the number was odd, we can simply say no, because the answer won't exist. And if we are over here, we know that if s dash is equal to s by 2, we can simply say cout s. We don't need to perform any operation. The array is already in a good position where the first I numbers are having some s by 2, and of course the first half is having s by 2, the remaining half will also have s by 2, and we can simply print return 0. Alright, if this is not the case, of course it will be the smaller or greater. Let's have those cases. If s dash is less than s by 2, then what we are looking for is some x. Let's have long x. Long x equal to s by 2 minus s dash. So s dash was smaller. Of course we have to delete element from second half and insert into first half. Sorry for this wrong spelling of half. I'm not correcting it either, but I'm not correcting it. So what we are looking forward is if second x is greater than 0, if this number exists in the second part, we can simply print yes and we can return, right? If not, then we can't do anything. And in else, so if s dash is greater, so we have to delete element from first half now. So let's quickly calculate y. Now y is nothing but s dash minus s by 2, right? And now we have to check if first y is greater than 0. We can print yes, because yes, y exists, and we can remove that to make the sum of the first I numbers as s by 2. To be honest, first I minus 1 in this case, because we are removing a number, but yeah. And over here what we can do is, now we can do something like first of ai plus plus. Now the ith number gets inserted to our set, right? Now so now what we can do is we can do first ai plus 1 plus plus, so that we are in so now we have to basically, we are moving to I plus 1, and I plus 1 has to be inserted in the first part and removed from the second part. So that's what we are doing over here to maintain the authenticity of both structures or both maps that we are having. So once we have done that, if we are still here, it means we can't do anything and we print no. So I think this should work. Let's see if we are having any errors. Alright, so this should work. Let's quickly submit this in Codeforces. Let's see if our code works. So we're getting wrong answer on test 21. So we got wrong answer, and let's quickly check what can be wrong with our code. One of the mistakes that I'm seeing is we are just iterating on the first n minus 1 prefixes. So this should be n. It can be the case that we are considering the full array as the prefix. So we can also iterate on the full array itself, and that sum will be of course greater than s by 2, and then we might remove some element which is exactly s by 2 in the array and make this work. So one mistake was right over here, wherein we can have something like some numbers are here, then s by 2 exists, and then we have something like this. So we need to iterate on the whole array and then remove s by 2 from here and then put it at the second part, and this is the first partition and this is the second partition with just one number. So we were missing this case. That's one thing which was wrong with this code. So I from 0 to n it should iterate at everything. What else are we doing wrong over here? Also, since we have done this and we are doing AI plus 1 in these lines, it's better if we increase this size to maybe 1 or 2, maybe let's for safety 5, so that we don't incur some segmentation fault. And another mistake that can happen over here is, since the numbers are up to 10 to the power 9 and we can have 10 to the power 5 such numbers, this long number can be really big, right? S dash can grow a lot, and s by 2 and the difference with s by 2 can still be greater than the int limit. And since our maps are defined from int to int, when we pass a long over here which is like really big enough, it can overflow and it can cause some weird issues. So it's better if we have a map from long to int. And now let's see if this is working on. It's running on test 3 and it got accepted. So as you can see guys, we just solved this problem. It took around 327 milliseconds to run. And now let's also quickly see what will happen if we convert this to an unordered map. So right now this solution is taking n log n time, but once we do it and once we use unordered map, I think it should speed up if collisions do not occur. But let's see what happens. So I have submitted the solution. It's running on test 13. Let's see what happens. 17, 43. Come on, get accepted. 45, 105, 111. How many tests? Oh, it got accepted. And as you can see, once we used unordered map, this like really got speeded up. These are my submissions with submissions with ordered map, and as you can see, the normal map is a bit slower as compared to unordered maps, as you can see from the time over here. So guys, I hope you like this video, and now you are really masters of maps, unordered maps, vectors, sets. Let me know in the comments if this video was useful to you, and I will see you next time with another episode on C STL.